Hello guys, welcome to my channel Learning with Nirvan. I'm Nirvan and today I'm going to start this lesson with a Sanskrit shloka. Kak cheshta bako dhyanam, swaninda alpahari, grahe त्यागी विद्यार्थी पंच लक्षण. अर्थात काक की तरह हमें चेष्टा रखनी चाहिए. We should be clever. काक चेष्टा बको ध्यानम, बको मतलब बगुले की तरह हमें ध्यान केंद्रित करना चाहिए. We should be focused on a one single task. स्वानिंदा हमें कुत्ते की तरह अटेंटिव रहना चाहिए. स्वानिंदा अल्पाहारी हमें कम खाना चाहिए. गृह त्यागी गॉसिप से दूर रहना चाहिए. Now we are going to start our class 9 lesson with the first chapter of maths, that is number system. Number system is divided into three main topics, that is rational number, irrational number and number line. So now let's start first with the rational number. Rational numbers are those numbers that can be written in the form of p by q, and with these both variables, right now these are variables, but later they will be integers, and this q denominator will not be equal to 0. That is a rational number. For example, 0. 0 is a rational number since we can write 1 under 0. That is a rational number. For example, 2 by 3. 2 by 3 is also a rational number. So simply we can say any number we generally see which is not in the form of root, that is called a rational number. So now we have learned about rational numbers. Rational numbers are the numbers that can be written in the form of p by q, okay? But irrational numbers are just the opposite of rational numbers, okay? So irrational numbers, we say that a number can't be written in the form of p by q where q is not equal to 0, okay? So for example, we can say that under root 2 is an irrational number. Under root 5 is also a rational number, and even pi, which we say the value is 22 upon 7, but when we divide that number, it keeps going on and it becomes an irrational number because the remainder never comes up to a 0, hence it is an irrational number. Now a question comes up to us that if we know that what is rational number. Now we need to find two rational numbers. Well, we need to find rational numbers between two numbers. So what is the method? How will we do it? So it's simple. Now we have given the number 1 and 2. So the number is 1 and 2. Okay, there is a method that we do half divided by r plus x. Okay. Now what is this r and x? R and S are the numbers that we have given in the question. Right now we have given 1 and 2. So we will suppose that R is 1 and S is 2. So if we put the value 1 plus 2, half 1 plus 2 is 3. So one number we get is 3 by 2. Okay, now suppose we need to find one more rational number between 1 and 2. Okay, so first of all there are infinite numbers that we can find in a two rational numbers. Okay, so the first number is 3 by 2. Now again we need to find one more number. So what will we do? We again use this method, half r plus s. Okay, now earlier we had supposed that r is 1 and now s is 2. Now we have got one more value, that is 3 by 2. So we'll suppose that this 3 by 2 is r, and still we'll suppose that the s is 2. Okay, now what we'll do? We'll do 3 by 2 plus 2. Okay, this. Now when we get ever plus, we will first take an LCM of both the numbers. Alright, so by taking the LCM, 1 is the denominator, the LCM is 2, 3, 4. Okay, now half 3 plus 4 is 7 upon 2. Okay, and the number we get will multiply the both. When there is a direct bracket in front of a number, then we need to multiply. Until there is no sign, that means we need to find the product. Okay, so simply we'll do 7 upon 4. Now we have found two rational numbers between 1 and 2, and they are infinite numbers, so we can keep on finding. Okay, so we know that how to find rational numbers between two such numbers. Now we need to represent an irrational number on a number line. Okay, in 8th class we know that how to draw a number line and just simply make a line and then denote the numbers especially. But here we have an irrational number, that is under root 2. We need to draw it on a number line. So simply we will draw a line. Just imagine this is 0, this is 1, 2, and this is 3. Now for just assuming, because it is a board and I cannot draw properly, so these all lengths is equal. These are equal in lengths. Now we know that the square of hypotenuse is the sum of the other two square of the other two sides. Okay, so for just assuming, under root 2 is equal to 1 square plus 1 square. Okay, or to prove, we know, just leave this, we can write hypotenuse for here and square. So for finding hypotenuse, the square, we will put an under root 1 plus 1 is 2. So we know that what the hypotenuse is equal to perpendicular square plus base square. Okay, so here we have the base 1 and the perpendicular length will be also 1. So if the base is 1, then here on the number line we'll take the number 1. So we will draw a line perpendicular on the 1, and then this equal length we will same do it here. We do this thing with the help of a compass. We take the compass length, put the pencil, make an arc, and then from a scale we will simply match it. Okay, this we will again take the length from the pencil, we will draw a line towards here, and this is under root 2. Now you can denote it from alphabets. For example, this is A, this we can take B, C, and this could be D. Okay, now we can simply write that AB square is equal to AC square plus BC square. Okay, AB is equal to AC means 1 square plus 1 square. AB is equal to under root 2. Here it was a square, so we'll put the number into under root. Simply this is the method how to prove under root 2 on a number line. So now our next topic is decimal expansion. There are two types of decimal expansions, that are non-terminating recurring decimal expansion, and the second one is terminating decimal expansions. Okay, so non-terminating recurring, the non word comes non. Terminating means ending. Ending, we can just consider that there is a we are just dividing a number and उसका जो remainder है that is coming up to a 0. That means terminating. वो decimal expansion is end, खत्म हो चुका है, ठीक है. So that non means जो खत्म नहीं हो रहा है, and that number that keeps on repeating, बार बार repeat हो रहा है, that is called non-terminating recurring decimal expansions. Terminating just comes at खत्म हो रहा है, a number we divide and just we come up with an answer, that is called terminating decimal expansions. So some examples of non-terminating recurring decimal expansion could be, we can just write any number of our own choice. There's a question I write irrational number, so we can just write any number of our own mind, whatever comes, and just remember to put dots, that this number is keeps on going on and end nahi ho raha hai. So this is a non-terminating recurring decimal expansions. And now we come to a terminating. Just simple, a number aa raha hai and keeps and comes to an end. 2 ho gaya, 5 ho gaya. What if we divide 10 by 2? This comes up to 5. So this is also example of terminating numbers. Now we need to find the decimal expansion of these two numbers. The numbers are 10 upon 3 and 7 upon 8. Okay. So what we'll do, we'll just simply divide both the numbers, and then I just taught you that is it a non-terminating number or is it just a terminating number. So just we need to find that what kind of decimal expansion is it. So simply first we'll divide this number. Now 3 3s are 9, 1.0, 3s are 9, again 1, then 0 will come, 3, then again we can do 3 3s are 9, and 1, 0, 3. So we have just gone till 3 decimal places, and I have noticed that the 3 number is keep on repeating. So we can just say that it comes under non-terminating decimal expansion. Okay, non-terminating means it never ends. See, the remainder keeps on going on and it will never come to an end. So simply we can write, this is non-terminating, non-terminating and recurring. Recurring means keeps on repeating. Okay. Okay, so simply we can write that this number comes under non-terminating recurring decimal expansion. The first one was a non-terminating decimal expansion, and now the second question is 7 upon 8. Just simple. Again we'll divide. It doesn't go in the table. We put a decimal. It goes to 70. 8s are 64. 6 again 0. 7s are 56. 56. 4s are 5s are, and goes to 40. We have noticed that the decimal means the remainder has come up to an end and the remainder is 0. So this kind of decimal expansion is terminating. Terminating, I told you, it comes to an end, khatam ho jata hai. So in this case it is a terminating decimal expansion. So we can just write terminating decimal expansion. Decimal expansion. Okay, so now we have given a question. Show that 0.333 can be written in the form of P by Q. P by Q means rational number. So just we can, this is an irrational number and we need to convert it into a rational number. Okay, so this number 0.333 and so on, it will keep on never ending. Okay, so we can just simply write it 0.3 bar. This bar indicates that this single number keeps on repeating. Okay, so just let us assume, let x is equal to 0.3 bar. Okay, just let's take it to the equation number 1. This is our first equation. Okay, x is equal to this. Okay, now we will multiply both sides with 10. Now you will ask, why with only 10? Why not 100? Why not 1000? Why not some other number? 10 because this is on a single digit number. The bar is only on number 3. Only a single bar. That is why we multiplied with 10. Okay, if it would be one more number ahead, for example, it would be 0.34 bar. So we will multiply in that case with 100. Okay, but right now we don't have this. We only have 0.3 bar. Okay, so we'll multiply it with 10. So the answer would be 10x. It would be 10x because we are multiplying it with both sides. 10x is equal to 3.3 bar. Now because it is infinite, if we multiply that one, 3 will come here and the other side of the 3 will replace that side. Hence we can write it like this. We will do this. Okay, this is equation number 2. Now we will subtract this equation from this. subtracting equation 1 from equation number 2. So we can write subtracting equation 1 from equation number 2. So we can write 10x is equal to 3.3 bar and x is equal to 0.3 bar. Now when we will subtract, 10x minus x would be 9x and this would be cancelled because minus again. So we can write 3.0. Now if you want to find the value of x, because we need to convert it in the form of p by q, where q is not equal to 0. Okay, so we will write x is equal to 3 upon 9, or we can just do it, simplify, the answer will be 1 upon 3. We needed to convert it into p by q, and what's our answer? 1 by 3, that is a p by q form. We can write hence proof. Okay, now there's one more question for us. Find irrational numbers between 1 upon 7 and 2 upon 7. Okay, so we need to find irrational numbers. Irrational number we can find there are infinite irrational numbers between two such numbers. Okay, so if you want to find number, so first we can just divide this number, that is 7 divided by 1, 0, 1 za 7, 3 0 4 za 28, 20, 2 za 14, 6 0, 8 za 56, 4 0, 5 za 35, and we get 5 0 5 6 za 6, 7 za 49, and then 1 0. Now if you might have noticed that it was 1 0 starting with 10 tha, and in the remainder we have got 10. So hence what we can write, simply then again the number 10 is repeat हो रहा है 10 number, so we can just write simply 0.142857 bar, because this number will again repeat. If I again divide this number, 7 1 जा हो जाएगा 10, है ना? So this will keep on repeating. So this method we can just say that we can apply on bar to have trouble. Okay, so our second number is 2 upon 7. We can just say that 1 upon 7 divided by 2 will be the decimal expansion. Okay, so just simply we can 1 upon 7 की बजाय we can write 142857 bar, okay, into 2. So when we multiply 8, the answer would be 0.285714 bar. Okay, so now this bar we have the number 0.142857 till 0.285714. Okay, so bar I didn't apply here because we need to find irrational numbers. Okay, so suppose we need to find 4 irrational numbers here. Okay, so we will not count the same numbers. Okay, 7 है 5 7 end में, so we cannot write the same number again. Here 1 4 है, so not like this. Okay, so just suppose I can write a number 1 5 3 2 1 4 6 2 4 8 and so on. See, it should be under this and above this because we need to find a number. So this would be our first number and we need to find one more number. So we can just write 1 2 3 4 5 6 4 2 8 9 1. So on, we can just think of our own choice between these two. They are infinite numbers, I'm telling you, we can not even imagine. So this is the method how to find irrational numbers. These are the points we should remember. Okay, these are the, you can say, formulas that we use it in the question for solving or simplifying an equation. Okay, so you can write it in a specific notebook where you can keep on revising, and when you need this, when you need the help, you can use this. Okay, So simply we write under root AB is equal to under root A into under root B. Just multiply. We can just, it is another way. Okay, for example, we can write under root 20. How can we write this? We can write this under root 5 into under root 4. Okay, simply 5 into 4 is 20 and under root 20. Simple. Now under root A upon B is equal to under root A upon under root B. Okay, so let us understand. There is an equation example. This is it. Under root 2 upon 3. We can write it for another way, that is under root 2 upon under root 3. It means the same, but there is another way, another tarika, another way how can we write it. Okay, under root A plus under root B into under root A minus B is equal to A minus B. Okay, just note, when we multiply a same number, for example 6 into under root 6, will not give the, it will give us under root 36. Okay, and under root 36 is the square of 6. We can just write it simply 6, because when we multiply the square or the same number will come as a whole number, not in an under root. Okay, so here under root A plus under root B and under root A minus under root B gives us A minus B. This is the formula that we studied in class 8, A square minus B square. So same, when we square, the answer would be this. Now A plus under root B and A minus under root B. We don't have under root here, neither there. Simply we'll just square this side, and this under root and this under root will be minus. Plus minus gives us minus. Just remember to put the right sign. Under root A plus under root B into under root C plus under root B. Okay, now we can use this distributive method of multiplying that we studied in class 8. Here what do we need to do? Just under root AC plus under root AD plus under root BC plus under root BD. We will multiply this number. Under root A will take common. Okay, then we'll multiply it under root C plus under root D. Then we have plus under root B under root C plus under root D. This is the distributive method to multiply. The answer would be under root AC plus under root AD plus under root BC plus under root BD. So this is the same answer that we have got here. This both are same. So this is the method how we can do this. Okay, under root A plus under root B ka whole square is equal to A plus 2 root AB plus B. This is the method, and I am sure that this formulas will help you. So just remember. Okay, now we have two questions with us. Simplify 5 plus under root 5 into 5 minus under root 5. Second question is rationalize 1 upon under root 2. Okay, we learned the identity number 4 that A plus under root B into A minus under root B gives us A square minus B. Okay, B ka matlab under root B ka we have just done a whole square. Okay, so right now A is 5 here and under root 5 is B. Okay, we'll suppose that 5 square, right now we are using this one, minus 5. 5 ka square is 25. 25 minus 5 is 20. Proved. Second question is rationalize 1 upon under root 2. How we'll do this? Simply under root 2 or any number that is under root in the denominator shouldn't be. We just need to take this under root somehow up, or this under root shouldn't be there. Okay, what we'll do, just multiply the same number under root 2 with the other side. 1 upon under root 2 multiplied by under root 2 upon under root 2. The same denominator we multiply it with the numerator and the denominator both. Okay, so under root 2 multiplied by this is equal to m2. See, earlier we had this under root 2 here in the denominator, and now we have only 2. Simply we just need to rationalize the denominator. Done. Okay, so now there are key points of exponents. Exponents mean powers, we have learned in class 8. Like for example, there is 5 square, that is 25. This 2 here is called an exponent, or generally people say power. 5 to power 2 is equal to 25. Okay, so there are some rules to be followed. That is, for example, a to the power p plus a to the power q. Now if you have noticed, this a is called the base. Base in both the cases is same. When added, the base would be same and the powers would be added. P and q are different powers. For example, there is 4 plus 4, the power is 2, and this 3. So the base is same. So we will simply write 4 and the powers will be added, that is 3 plus 2, that is 5. So this would be an example of this first. Second, AP into Q. Okay, so what we'll do? Multiply this P and Q will be going multiply. So this base would be A same, the base would be same, and we'll just multiply the top powers. Okay, for example, 2, we'll write 2 here and 4 here. This would come to an answer 2 to the power 8. We'll multiply 4 into 2, that's 8. Okay, third, AP upon AQ is equal to AP minus Q. What we have done, this Q will go up to the minus Q. Just remember that any exponent that is divided, it will go towards the numerator upside and it will be subtracted. Okay, again let's do an example. Just take 3, 2 upon 3, 3, 1. Okay, so 3, 2 minus 1 is equal to 3, 1. Or we can just simply write 3. Okay, fourth, AP into BP. Now if you have noticed, this base is different. What we'll do, and the powers are same. What we'll do, that we'll multiply the base and the powers would remain same. For example, 2 divided by 5, 3. Okay, what we'll get the answer? Sorry, base power would be same. So we just multiply this. That is 10 square. That is equal to 100. Okay, this is the way, the rules we need to follow while doing an exponent power. Now let's come up to a question. The question is, we need to simplify 2. Let's write here first. 2 upon 3. Okay, we need to simplify this. How will we simplify? 2 1 by 3. We need to multiply and simplify, whatever you can say. So this is the power. If you have noticed, the base is same and this power are different. Okay, what we'll do, that keep the base same. What we have learned here, if the base is same and this both powers are different, they would be added. So what we'll do, just take the LCM of the both of the numbers and do. Okay, so 3, 2 plus 1. So the answer would be 2, 3 upon 3. Or just we can write 2. Okay. Now second part is, second question we have here is 3, 1 by 5 and 4. Okay, so this 1 by 5 is really too big. This is a power, you get confused. Okay, so this we need to multiply it when the base is same, or just you remember that the outside is nothing and it's a whole square. But it's a whole 4, power to the 4. Okay, so what we'll do, 3, 1 by 5 into 4 is equal to 3, 4 by 5. What I've just done, I'll multiply this and the denominator में 5, this side is 1. So 5 into this and this into this. 3, 4 upon. That's all for this introduction of the chapter number system. And if you have any queries, doubts, and you want to give me suggestions, do mention it in the comment box. And do like, share, and subscribe my channel, Learning with Nirvan. Thanks for watching.